All right. Well, thank you, Nicholas, for inviting me. So, as was mentioned, I've been doing software craftsmanship, what we used to call extreme programming, since the late 90s, doing TDD for quite some time, although I still feel like I'm learning about it. This talk isn't specifically about TDD, but you can't do TDD if you don't keep your tests in good shape. And one of the things that I think I know I've been prone to it. I still make these mistakes. We are still human. Is not keeping our tests in good shape, refactored, protecting against change, adjusting as we build functionality. We sometimes don't notice that our tests are getting a little bit harder to write. They're a little bit longer. They're a little bit harder to read. And so I spend a lot of time thinking about how can we make the test better, because like any refactoring, you have to do it to get better at it. And you have to kind of know, in code we have these idea of code smells, and so I'm going to talk a little bit about also some of the test smells that come up. And so there'll be time at the end, as Nicholas mentioned, for questions. But if you have like a quick question that you want to write in chat, I've got the chat window open, so I'll keep that in my eyesight. And so feel free to ask a question in chat. If you ask a question in chat, then I might say I'm going to cover that, and then we'll have time at the end to see what I've missed. So the examples I'm using here are in Java. I'm a Java developer, been doing Java for 31 years. And so the code examples are JUnit and an assertion library called AssertJ. But really, it works. A lot of these concepts and ideas work with any language. Depending on the language, you're going to have sort of different libraries and different requirements. Some things are going to be easier in your language than perhaps they are in Java when you have a statically typed language, but the ideas hopefully will translate for you. And so one of the things I think about is, even though this looks more like stair steps, I always think of the ladder of refactoring for tests. And so it starts with, like, we just need to structure our tests in a way that is readable to us. I was taking part in a class, and I was working with someone who was relatively new to TDD. And one of the things that stood out to me is the test he was writing, my pairing partner was writing, was fine, but I actually found it was a little hard to read because it was all compressed. And so one of the things that we'll see is like how you just structure your tests. White space really is important to us, right? Somebody asked in chat before the meeting started about AI. In this TED Talk, there's no AI. I may take questions about that, but I think it's really important, especially for tests, that we understand that it's still, the tests have to be meaningful to us. We have to understand them. And so therefore, we need to have things like blank lines and white space and format things and name things nicely. And so structuring the test is sort of the baseline, the first step. And then better assertions. One of the things that really test-driven development offers us is the opportunity to see a failing test. So you'll notice I'm wearing a hat that says change behavior, and it's red, right? The red portion of test-driven development is when we are saying, I want behavior, and I'll know that behavior works when this test passes, but right now that behavior doesn't exist, so the test fails. And it's a great opportunity to say, is this failure readable? And this is something that you don't often look at when you're writing the tests afterwards, right? So you've written some code, now you want to write some tests that confirm that behavior is working the way it should. And from that standpoint, you hope you never see the test fail. But I think seeing the test fail, besides all the good reasons related to test-driven development itself, it's great to see, does this assertion make sense? And we'll look at that. Simple abstraction. So we can have abstractions in test too, right? So there are some differences between test code and production code, but some of them still, some of these ideas apply to both. We'll look a bit at test builders, which are not true gang of 4 software design patterns builders, but we'll look at what they are, and we'll look at some interesting ways to use them. And then custom assertions. And so again, this will be something specific to AssertJ, but the idea is exactly the same for any language. You want to make your assertions really nice and readable and understandable. And so one of the things that you want to think about is like, well, what makes a good test suite? Right. So good test suites are safety net for system behavior, right? That's one of, whether you're doing TDD or not, they're this safety net so that when you do things like refactor, that they catch problems, right? So the whole point of refactoring is that you can change the structure of the code to make it more readable, to make it more understandable, to make it more flexible, without breaking your tests. The problem is sometimes refactoring the code causes tests to break, and not because the behavior is broken, but because you've changed the structure enough so that the test now no longer matches. In the Java world, this is most often, in my experience, you change constructors, or you change some of the constraints and variants upon creating an object that you're going to test. Living documentation, right? I mean, if the tests run and they pass, and they're readable, and they have good names for your test methods, then they're some of the best documentation you can have. Especially if you're using ubiquitous language. From domain-driven design, using language terms that come from the domain. You want them to be comprehensive, right? Code coverage is interesting. I use it sometimes as a guide, especially when going into code bases that might feel like they're under-tested. But code coverage is not the be-all, end-all. There are other mechanisms you can use. Property-based testing, which is useful. Mutation testing, which is useful. But you want to you want your test suite to really have comprehensive coverage. And of course, I'm a TDD fan, but you can't always do TDD, and so you do the best you can. So Brian in chat asks a good question. We'll cover that in a bit, but the idea of integration tests, and it's like, what is an integration test? And I'll come to that in a bit. The further away you are from specifics on the code, like at the center, then yes, it can be less prone to having to change them if that core changes. But it's a trade-off, and so this idea of having outer tests, I don't call them integration tests, I call them outer tests or IO-based tests, are really useful, but you don't want to try and cover everything, because there's this trade-off between sort of how much does it cover and how much can I tweak things and twiddle things and configure things so that I'm testing stuff that I want to test. A lot of times we test just the happy path, and so those kinds of tests are really nice for that. But what if you want to test the 35 different ways an API will fail, or the 18 different ways a database will fail? You don't want to do that by testing through your HTTP controller, or whatever you want to call it, at that layer. That's just really awkward, because you want these small, focused, fast tests. So you want this variety of tests. I am personally still a believer in the test pyramid, and so these outer tests tend to be less susceptible to refactorings on the inner layer, but you still want those more precise tests on the inner layer, and we'll look at some ways to help with that. And so I said this talk, I won't be mentioning AI much, but this is one place where it really counts. If you are using LLMs or agents, especially, helps with discipline, not just for you, but for your agents. In fact, this is really, as far as I'm concerned, one of the only ways to, rein them in is to say you must make all these tests pass. You make a change, you must, and this applies to whether you're dealing with juniors, agents, right? People not, the better this is, then the more likely you'll be able to make progress without breaking stuff along the way. It also, again, sort of with relation to the living documentation, it's really a way to understand the system. So I recently, so I do a lot of live coding on Twitch, and I'm currently working on putting the TDD game online. And I came back to the code base basically after about a year of working on what was supposed to be a side project. And the tests were really helpful in getting me back up to speed on what the heck were all the different pieces and how did they fit together. And we'll actually look at a little bit of code from that. So in addition to sort of the suite as a whole, there's some principles about individual tests themselves. And you may have heard about FIRST from Brett Schuchert and Tim Ottinger. They have to be fast. Not all tests are going to be as fast as you'd like. Although at least in the Java Spring world, we have, and we actually just, not even just Spring, we have test containers which can help some of the integration IO-based tests like databases or message queues or other things that generally took a lot of time to set up and get started can run much faster. But 5 seconds to run a test is still too slow for me. I want pretty much all my tests to run in less than 3 seconds. Because I do TDD, since that cycle of speed is really important. And so in general, we want our test speeds as fast as they possibly can. And when you start seeing tests slow down, you want to have some threshold where you start saying, this has crossed the boundary where we need to look at why are these slow. So for example, in Java, it used to be that in using the AssertJ tool, there's this idea of what are called soft assertions, where they won't stop your test if they fail, but they'll let you know that something happened, which is great if you're doing a whole bunch of assertions. You don't want it to stop at each one, you fix it, and then the next one breaks, and then fix that, and then the next one breaks. You'd like to get all of the problems up front. The older implementation took a lot of time to set up because of just the implementation details. And so I stopped using it. Apparently that's been fixed, so I'll probably use it again. But the difference was like 1.5 seconds. But that was enough for me that I'm like, I need to look at this and figure out what's going on. You want your tests obviously to be isolated, right? You want to be able to run one individually because it failed, and you want to be able to maybe quickly rerun it. But you also want it to be independent. So there are a couple of meanings that I attribute to this one, which is each one should be able to run in any order. It could almost be random, and it shouldn't matter. But you also want them to be readable in isolation. One of the things that I used to do, and I think is, and I now look at it as being a mistake, is putting a bunch of things in a base class and then extending that where there's meaningful information in that base class. And so now you're looking at this test and it's like, why is this failing? And you don't even understand what it's doing because it's partially there. And there's other parts perhaps spread into multiple other places. And so sometimes even like in a file, like I've got a bunch of JSON. It's like, if it's not that long, I'm going to stick it inside the test instead of having it as a separate file that I might read while running the test. And so readable in isolation, I think, is really important, because if I have to start looking in different places, I may miss a place, and now I misunderstand the test, or it's just really kind of distracting, and then takes me longer to build the context that I need to understand it. Repeatable is obviously important. We've all probably encountered flaky tests. Flaky tests are something you should fix and not just ignore. I worked at a company where we had an annotation for flaky tests, and we at some point fixed those. But you got to fix them at some point. Maybe postpone it for a bit, but you don't want to let that build up. Because now it's like, is this test failing because it's just flaky? Why is it flaky? What's going on there? And understanding that often, in my experience, reveals that you haven't quite understood what is non-deterministic. And you probably want to take a closer look and say, am I missing some test doubles here? Right? Some people call them mocks. I call them test doubles. And you might be needing to take a closer look at that. Self-validating, we sort of take for granted these days. Basically, like you have an assertion, so therefore it'll either pass or fail. If you're using certain kinds of test doubles like mocks, those should be self-validating. But again, like I've kind of gone away from putting the self-validation in mocks, because again, that if it's not clear, then now I have to go to some other part of the code to figure out what is it actually validating? What's it asserting? So I kind of want to see the asserts in that test, right? That readable in isolation. And timely means all sorts of things. One is, if you're not doing TDD, you write them right after you write the code so that it's fresh in your memory. Although there is an advantage to not writing it right after your code, so you've forgotten the implementation a bit, and now you can only really think about it from the outside. But at that point, maybe you should just try TDD. And Kent Beck has his own test desiderata layout. I'm not going to go through all these. You can go read the site. But it's all the same idea. I really like the idea of habitable, right? You live in your code, you live in your tests. I actually live probably more in my tests than in anything else, because that's what I'm constantly working on because I'm doing TDD. And so I think making it not a frustrating experience to live in that test code, I think is a good ideal. So I mentioned test structures, and you're probably familiar with one or more of these. So range act assert comes from Bill Wake. At least I first encountered it there in 2001. Sometimes called 3A or AAA. The problem I have with that is when I use it, when I was doing teaching and I use this technique, or at least this name, people would get confused because they're all A's, and so you don't know which order is which. The given when then is really nice. It comes from sort of the rephrasing of TDD into BDD to try and recapture the idea of TDD. So that was Daniel Torres North who basically did that in 2006. BDD is TDD. It's just refocusing on behavior. That's the important part. Given when then has actually sort of made a comeback in my world because I'm doing a lot now with event sourcing, and event sourcing has invariance expressed as given when then. Given this event, these events have occurred in the past already. When we execute this command, then we expect this event to be generated because it's all about events. We're not actually checking state of something, and so that's something that I now use with my event sourcing code. I came across assemble, activate, assert on the good old C2 wiki, which is still around. And then Gerard Mazzaros, who wrote the classic tome, and I do mean tome. It's, if you've ever seen it, it's 900 pages. The XUnit test patterns book talks about setup, execute, verify, and teardown. I honestly don't do much teardown. Mostly might be some setup for databases, getting things up and running. But because these external things like test containers that have the databases in them are disposable, generally don't have to tear down. The system does that tear down. And so we end up with just setup, execute, and verify, which is pretty much the way I think about it, except I changed the verify to assert because that way when I'm talking about it, it's easier for people to relate to the actual assertions that you write. And so setup is basically you prepare your objects for execution, because the whole point is you are going to execute. There may be little or no setup, because your setup might be you instantiate an object, and that might be what you're testing. For example, if I create an order, well, there shouldn't be anything in it. That's a test. It might be a very simple test, but without that, you can't then rely on the fact that if I add one, there should only be one in there. Well, how do you know it didn't start out with one? Maybe all orders start out with something in it, right? A free gift. Let me tell you, this confuses people as to why this test that you're writing, that it says, oh, well, when I add one item, it should have one, and now it has two. Now you're really confused, right? So those baseline simple tests are actually really important. And then, of course, we assert, which is what we want to observe. And the observe is really important. So in my TDD game, there's a red card, which means something bad has happened or you've discovered something, which is you can't assert. Which means there's something that you want, there's some behavior that you want to check through an assertion, but there's no method you can call. There's no place you can look for that information without sort of going behind an object's back or going behind some code's back. And it's like, that's really kind of bad. Don't do that. Maybe you could look in a database. Maybe that's okay, depending on the test, but it means that maybe there's something wrong with the structure of your code. And that's a signal that we want to listen to. And so one of the things that when we're writing tests is when something is hard, don't blame the test. It might be the code's fault. which may mean that you have to go and restructure and refactor your code to make something accessible. There are a bunch of techniques, because maybe there's a side effect that you can't directly observe, but you can sort of indirectly observe it. That might be useful. James Shore has a whole bunch of patterns on what he calls testing without mocks, which is a bit clickbaity, but really solid ideas. And one of them is this idea of an output tracker, where I can't monitor what it did directly, but I can tell it to sort of keep a log of the things it did, and then I can examine that log. Interestingly enough, event sourcing gives you that for free, because every outcome, or at least every usually successful outcome of some command, right? The command succeeds, then event sourcing outputs an event, and that's very easy to examine. So your basic SEA test is this, right? So this comes from an application I developed to manage mob programming ensembles that I run. I very much believe in writing tools that you use and that help your life. And so this one is one of those really basic tests. When I create an ensemble, it better not be in the completed state unless I actually complete it. So I actually have a test where I create the ensemble and I say, are you completed? And it's false, which then allows me to write this test, which is when I create an ensemble, right, the setup, and then I execute, okay, you're now completed, then I should be able to observe the state change of that object, that it is completed is now true. And so one of the things you may notice, besides having a nice name, names are hard. And for me, test names are probably one of the hardest things to name, because you're expressing often a full sentence, especially as they get more complicated behaviors. So I always say, don't be afraid to let them scroll off screen horizontally. That's fine. Some people like to separate certain portions by underscores. Other languages have ways of using full, spaces in your sentences. And there's always the not quite trade-off, but sort of struggle that I have. It's like, do I start with the outcome? And so say ensemble is completed when telling the ensemble that you're completed. And I go back and forth. I mostly these days land on sort of the outcome first, because one of the things that you have to think about is when you're writing the test, you're writing the test often just once, hopefully. You might rewrite it, you might modify it, but you're typically writing it once. You're looking for them a lot. Like, this thing failed, what's going on? But then that points you to the failing test. In my experience, the tests don't fail very often because I'm doing TDD, unless I'm part of the red part. But when I'm looking to add behavior, I'm trying to figure out what behavior is already there. Like if I want to change something about when an ensemble is completed, where is that behavior? And so if the sentence starts with when the ensemble is completed, right, or the ensemble is completed when calling ensemble complete, that sometimes can make it easier to find things. Your experience may be different, and I encourage you to again, when you're struggling with things, take note. These are inputs into ways that you can improve things. And so one of the other things, and this I'm not sure if this is what Jeff was necessarily pointing at in chat, but basically you have to also be careful of, and I'll talk a bit more about this later, is this information relevant? So one of the things that can make tests harder to understand is, as part of your setup, you're going to do a bunch of things. And as the thing that you're setting up to test, right, when you have an object and it's an initial state, that's usually easy to get to. But if you have to push it through multiple states to get to a certain point where you want to then test from there, that can take up a lot of setup. And so irrelevant information can sometimes sidetrack you. And so this name of the ensemble is actually irrelevant for this test. And so I would, looking at this now, and sometimes you have to look at it fresh to understand that, is that's irrelevant and should be marked as such. Because it can be confusing. Is that string important? Do I have to specify that string? What even is that string? If you're not familiar with it, then you're going to have to start browsing around and saying, oh, this is a constructor. Oh, this is actually the name of the ensemble. Oh, who cares about what its string is? And so labeling these things as irrelevant or unimportant is really valuable. Yeah, clearly I confused a couple of people in chat. So good on you for getting confused, and bad me for not refactoring it. And again, I think this is a really important point, is we're never going to get it right the first time or second time. And sometimes, especially when we're involved in writing it, right? All the context is loaded in our head. We have a good understanding of where things are and what's going on. It's very easy to write tests that make sense only when you have that full context loaded. And then if somebody else is reviewing it, or you're pairing with somebody, or you come back in like a month or a week, if you have a bad memory like me, you may look at it as like, was that important? And if you notice that, and then you realize, oh, it wasn't, well, go and fix it. Don't wait. Don't put it off, and don't just say, oh, I just didn't understand it, now I do. Make that change right there. So this is another basic SEA test. So again, we've got the 3 parts. We've got the white space in between, making it nice and easy to understand that these are 3 parts. And so this one is about the TDD game, where one of the rules is when you discard a card, you move from one tile to another. And that's what this test is doing. And so in this case, it's not even instantiating anything. It's just grabbing an enum, because the code is actually in an enum. And so as I mentioned before, here you got a test where we want to test that a new ensemble is not canceled and a new ensemble is not completed, right? And one of the things that leads you to writing this, if you're not already familiar with zombies from James Grenning, 0, 1, many is really the key part. There's some other aspects to that acronym, but 0, 1, many, that 0 case, again, is really important. If you find yourself in a setup portion of your test, or the given portion, whatever you want to call it, and then right after that, you're writing an assertion, because I want to make sure that setup was correct. You've just discovered a test that you're missing. Because if you had a test that tested, given this setup, then this is true, then you wouldn't need to assert that. You know that if you set this up this way, you've got a test that already tests what the outcome is, right? We build on these foundations. And so if we don't have good foundations, we end up throwing in asserts because we're like not sure what's going on. And so pull out. If you find yourself, like after you do no ensemble in the other tests, right back here, if you find yourself right here saying, oh, I better make sure when I new it up, it's not completed, just so I can make sure that when I do complete, that it is completed, right, that actually change state, pull out a method, pull it out into a new test method. I generally do 0, 1, many, but I forget, and I'm writing, and I realize I'm writing something that actually is building on something that I haven't established as a fact. Sometimes you'll want to do things like embed your execute. And so sometimes the execute part, especially in Java with lambdas, may not be as obvious. And so sometimes you may have to do something like this. We'll see some more examples of this. But as much as possible, you want to make your test where you sort of squint and you see 2 or 3 portions, and you know exactly what those are. Okay. So that's a bit about the basics of structuring a test, and there's a lot there. But let's look at some test smells. And so hidden setup. So I was talking about this before, right? We've got this test here. It's telling us what the expected receipt is, right? This is, some, receipt for food items purchased. Well, where's the input into this? How do I know that this is what's expected? Is this okay? Is this reasonable? Is this all I need? And you'd have to know to look And if you didn't know to look, you'd go look and say, there must be something else somewhere that's setting this up. And it's, oh yeah, it's over here in this before each that's all the way at the top of the test that I didn't, or maybe even a base class that I didn't realize. It's like, oh, that's why this is that way. And so this is not great. And so having this separate may give you a feeling of like efficiency. In my mind, tests are not the place to necessarily be efficient. They're the place to be understandable. Because again, for me, they're generally your first line of defense. And so Nicholas asked the question, I'll probably go into it deeper later, but like, how do you get people to recognize this and do this? And in my experience, you model it. Like if it's a simple one, just pull it out into a constant, right? That completed name, just pull it out into a constant called irrelevant name. Very clear right there that there's some name required here. Maybe it's a string, who cares, but that it's irrelevant in the context of this test. And a lot of times these simple things, they don't, especially in tests, you don't have to worry about breaking some production behavior. So I find that there's a little bit more freedom to do some of these changes, and you just do them and show them. And basically, if you've got weekly sharing opportunities where you give presentations to each other, or you have opportunities to show people, or even during pairing or pull request reviews, show the before and after. Human brains are excellent at detecting patterns and differences. And so if you say, which one's easier? Look, this didn't take much effort. Let's do this in the future. And it's not like you need to go back and fix everything. You do it as you encounter it. Yeah, redundant setup is sort of the downside, right? So we might say, well, let's just pull this in, right? So we inline the setup, and now everything's there. But not everything necessarily carries the same weight, right? You can look at this and say, well, it's Java, so it's verbose, of course, right? But you can also say, like, there's stuff here that's just not the content, right? What do we really care about? Because you can sort of step back from like, basically, where did each one of these pieces come from? Well, the bagel everything 250, well, that came from here. Is the cream cheese important? What the heck is this true? Boy, Boolean's not readable at all. I mean, the word is readable, but what does it mean? You have no idea, unless you go and look at the parameter list or click a button to show it to you. But just looking at it and like, I have no idea what this means. And actually, I don't remember what this means. And so same thing for cookie. I don't remember what truth. Does it mean you heat it up? Maybe that seems possible. But anyway, like there's a lot of things here that are definitely relevant. But there's a bunch of things that are not. Like actually, for some reason, the Americano is not on here. Maybe that's done on purpose. Who knows? Because it's only for food items. And so when you have sort of the unclear or undefined setup details, you basically want to give it names. So here we have an example of what the heck does this zone date time now? What does that mean? Like, okay, clearly it's some date time, but what does it mean? Does it mean when I scheduled it? Does it mean when it's going to happen? I mean, now you're just guessing. And so why? I don't want to guess when I'm reading tests. And so the easiest thing to do is just extract it to a variable and name it. And if you use it a lot, of course, you can extract it to a method. But like, give it a name. And this is possibly important, or maybe actually in this test, it's not at all important. So maybe it wasn't worth it. Another problem is the unclear assertions. The outcome, like the test here, failed for some reason. But if you just look at the output, you're like, great, true is not false. Thank you very much. Now I got to go look at the test. And if you're running it and your context is loaded in your head, this is not a big deal. But wouldn't it be nicer if you had some more information and, in fact, a little bit of extra documentation? So here it's saying, well, it was expecting an ensemble to be completed, but it was not. And so then that comes in our output. And various different assertion test unit runners will have this ability. Yeah, so Nara mentions the infamous mocks and outdated problem. And I have a quick answer, which is a bit cheeky, but it's don't use mocks, or at least don't use automated mocking tools. The long answer, I'll get to when we get to test data builders. Sometimes you'll have very similar tests. Maybe you don't notice it the first time, you wrote a test, and then sometime later you wrote another test, and then you're looking over the test. It's like, wow, these tests look really similar. Is that okay? Maybe it is. Right? Just because it's a test smell doesn't mean you fix it. It means you take a closer look. Is this okay? And maybe you're about to add a third one that's also similar. And it's like, okay, let's back up and find some way to parameterize that, right? Because here, for these two input values, basically whatever you do, you discard a card and you end up on some other thing, right? So there's something where you can test the behavior and they're similar across these inputs. Sometimes the inputs are just numbers and you're testing for failure. It's great for boundary checking. I think I have something like that in here. So here, do not allow invalid bet amounts. This is for a blackjack game. And so the values are -1, clearly invalid. 0, no, you can't bet 0. Go find another table. And this table limit is 100, so you can't bet 101. Right? So great to have these to basically, so you're not writing a bunch of repetitive kinds of tests. And again, sometimes, depending on your test runner and how you're running it, these are somewhat wordy outputs for the failure, but still not very readable. And so again, you want to add a description. So often adding descriptions not only improves sort of the documentation value of your tests, but when they fail, it's pretty obvious, or at least hopefully it's much more obvious. And every time you see a test fail, really closely read the assertion. And that's for two reasons. One is, does it make sense? Does it give you the information you need to say, I know what that is? And two is, like, did it fail for the right reason? Is this failing because it says, or is it failing for some other reason? I admit I'm often, especially with the Boolean checks of is true or is false, I'm lazy and I often don't add it. And then later on, I'm like, why did this fail? And then I go add it. So again, as you learn things, maybe you were lazy like me. Next time you run into it, just add it. Doesn't take that long. In my experience, LLMs are also lazy in this regard, and mainly because they're trained on code that doesn't do this. So you might have to add it yourself. What's wrong with this test? Like there are several things wrong with this test. But like if you look at this, like, what's wrong? Like I look at this and I'm like, why are there 4 examples? The test method name is terrible. And by the way, this is not something I made up. This is from a code base. Keep in mind, your LLMs are trained on this data. Test person. What is it doing, right? So it's unclear what its actual goal is. And there's nothing worse than encountering a test and not understanding what its purpose is. If you don't understand what its purpose is, then if it fails, you have no idea, is that okay? Because you don't understand the behavior that it's expecting. And so there are a couple of things we could do to clean this up. It's like, do we really need 4 examples? Is there something special about these numbers for their years, which presumably is their age, because we see that in the output? And it's like, okay, and I guess this is testing the render, but there's no blank space, so we can't see that really there's a separation here and then kind of a separation here. And so it's the render that we're checking. And so given that, it's like, I don't think I need 4. I think I maybe need a little bit of variety because I'm testing some rendering, but even so, again, what am I testing? Am I testing that it sticks Rick into some, you know, sticks the name into some text here? And so this almost looks like I'm actually testing two things, which sometimes is necessary, right? You're testing things individually, and then you test them that they work together. But it's really not clear. And so you could fix this up a bit, but I'd probably take a longer look, and it's like, really, what are we checking? What are we testing here? Why are we asserting this? But at least like a first stab is like reduce the amount of variation if that variation isn't important, right? Because it's like having a parameterized test where you test 1 through 100, but 2 through 99 don't matter. They're always going to pass. And so they're right. Only boundaries are important. Yes, you can have a good, nice, check, 13, see if that works. But otherwise, check numbers that are meaningful. So if we inline stuff and we've got everything there and it's readable in isolation, we might end up with some information that is a bit unclear. And so Kempeck talks about in his TDD by example book this idea of evident data. And doesn't come up a lot, but when it comes up, I find it really useful. And so instead of saying, given these cards, right, an ace and a 10, that I end up with 21, if you know anything about blackjack, you know that that's blackjack, that's 21. But it may be a bit unclear about, like, well, kind of why. Like, you could read this, but then it might require you to understand a little bit about the domain. Whereas if you split it out and you provide evident data, so like, why am I adding these up? Because then you can directly relate, oh, the 11 is the ace, the 10 we know is represented as a 10. And so you don't want to go too far. You don't want to start doing computations in your assertions. But some math, sometimes even string concatenation to do it that way, to make it evident what was the source in the setup that got us to these values, and can I relate them and make it easier to match things up. And there are a bunch of other ways to do that. So test data builders. I could literally, and I have, because I have it as part of a course I teach, could spend lots of time on this, but I'll give you the sort of the short view. One is, it is not the Gang of Four builder pattern. It's one of those, yeah, this is not a hill I'm going to die on, but it's like, let's acknowledge that the builder pattern from the Gang of Four book is actually rarely used, and test data builders are something different. I learned about test data builders way back in the early 2000s when I was at Google, and sort of carried that idea that they're sort of a special kind of thing. Sometimes it's known as the block builder because Joshua Block wrote about it in the Effective Java book, basically trying to solve the problem of these telescopic, as he called it, constructors. And tests have the same problem, right? You start extracting things to methods, right? Maybe you start extracting your setups into more convenient things that hide some of the irrelevant details. And that's great for the first time, the second time, the third time, maybe even the fifth time. You start having variations. Sometimes I want to specify this parameter. Sometimes I want to specify that parameter. And then in general, otherwise, I don't care. But once you end up with like 23 methods that have widely different parameter lists because each one is about, oh, I only care about this for this test, it's probably long past time to do something else. And I have encountered code where these little factory methods, these creation methods that are great because they hide irrelevant stuff. But now you've got like so many variations, it can become hard to know which one to use. And then you want to reuse them across tests. Well, then, okay, maybe put them in a factory class. And then it gets hard to know, like, which one do I use? And I want one that is different now. Do I now write yet another one? Especially for complex objects, this gets you into a bad situation. So Joshua Block wrote up the block builder pattern, and I don't generally use this in production code. Like, I know there are tools that can generate this for you, but I generally don't. But in tests, absolutely. And this is where I've gotten enough variation where it's like, okay, now I need something that's easier to build. And so this is the example actually from the book, Nutrition Facts. And so there's a builder. And one of the nice things about builder pattern is, especially in Java and in any language where you can do these chained method calls, right? We're generally in an IDE where you hit dot or something, and it auto completes the options from there. And so if I start creating a builder, I'm given the options that are available to me at that time. And with the builder, you can enforce that certain things kind of are required, right? You must have serving size and servings, otherwise nutrition facts makes no sense. And that's important because a lot of times objects have things like where you need to specify these things, or often in their constructors. And it makes no sense to build this thing without those pieces of information. Some of them are optional, like here, calories, whatever reason, are optional because maybe by default they're 0. And so builders give you some kind of guidance, right? What's required, what's optional, and then reasonable defaults. And so then the way to use it is you say new nutrition facts builder, you give it the required stuff, and then I say, okay, it has these calories, this amount of sodium, this amount of carbohydrate, and then build it and give me a nutrition facts. Very easy to read, great for diffs. It's like, oh, we needed to add potassium. So now that's a one-line change instead of some parameter buried inside of a method call that has 18 different parameters. And as you add them, you can add good defaults and provides resilience for refactoring. So anytime you extract a setup code into a method, you are now basically reducing the points of change due to refactoring to that one point. But if you have 23 of those, well, now you've reduced it to 23 points, which may not be as useful. But if you extract all of that building behavior, right? The setup is usually the part that takes a lot of time and takes a lot of care and is often the part that then is susceptible to refactoring. Because you change the constructor, we didn't used to require servings, now we require it. Ugh, now I got to change every single freaking test that calls this and every single method. But if it's encapsulated in a builder, then I'll have to change it in one place and can provide good defaults. Now in Java, there's a need for sometimes more advanced customization where you can't get away with just chained method calls all the time. Although you can get, having written some of these, you can go pretty nuts and have like sort of building not just a single object, but an entire graph of objects, and then sort of go down this tree. And you can do it. Sometimes it can get pretty complex, but sometimes you need to change something that is sort of an inner part of another object. And so that's where in Java we have this idea of a customizer. And so I have an app that I use for event sourcing, my event sourcing workshops and training classes called Jitter Ticket. And one of the things that I often need to do is create a concert, schedule it, but then there's a bunch of things that I need to do, like given this concert's been scheduled, sell a couple of tickets, right? Because I want to get to the point where not only is there a concert scheduled, but some tickets have been sold. And so I built a builder called Make Events and basically say concert scheduled. And then there's this part here, which is a customizer. So inside of here, you're now handed the concert that you can then further customize. And if you use Java and if you use Spring Boot, you'll have noticed that more recent versions of Spring Boot do this kind of thing for customizing configuration. And so it's the same idea. And different languages can make this way easier than Java. But the idea is the same. Is like make it so that, especially when you're building more complex objects, right? Can I build things, almost starting to build scenarios. And so here I can do things like create 2 concerts, but where the show date time is a specific time, and where we've stopped ticket sales for some reason. I won't bore you with the implementation. You can go look at it. The code is open source. It's not trivial. So it's complex on the inside, but simple on the outside. And that's what you want. And so in my TDD game, I have this game scenario builder. And so here, because the TDD game is a complex aggregate, there's a bunch of different things going on. And so we can do things like create the game with these cards in this deck, with these cards in this other deck that people draw from, where these people have joined as players and they've started the game and they've discarded, right? And so I have a builder that's really a scenario runner that gets me then to the point of, okay, now I can check when they play this card at this situation, what happens? And this is still a builder, right? I still have ways of building what I want. So here, when you draw a card, the top card from the draw pile goes into your hand. And so I build it, I say create the game, here are the action cards in the deck, member joins as a player, we start the game, they discard a card, right? Very readable. And again, if I refactor my code, likely this is still going to be the same thing. Maybe there's some new thing that happens. So when I was working on the blackjack game, we added betting. One of the things you know about blackjack is betting comes before the cards get dealt. And when we implemented that, a whole bunch of tests broke because they were trying to deal the cards because they weren't aware of this idea of betting, and it was added later. When it's protected inside of a builder, then we can say, okay, we'll have some default bets because these tests actually don't care about that, but it's a requirement of this, it's a new invariant of this object. And so we can put it into there. And it's all this idea of encapsulating this setup stuff into nicer objects that are then one place to change it, right? So I'm very fond of like repeating information in tests that's very relevant to the test. But what I want to protect against is ripple effects from refactoring. And so the last thing I'll talk about is improve your assertions. Whatever assertion mechanism you're using, if it is not readable, if you can make it better, then do so. So in Java, one of the things we do is we check for exceptions, right? At least I hope you do in your tests. Otherwise, you're just testing the happy case. But the exceptions are where the fun stuff is, for some definition of fun. And so here we can do things like test that when there's something wrong, we can say assert that thrown by. So this piece of code that gets executed not only should throw this exception, but also have this message, right? You test your exception messages too, don't you? Yeah. You can test specific types. So there are a couple of different ways to do it. If you're in Java and you're not using AssertJ, you should use AssertJ. And there's a lot of different ways to do things. And sometimes, we do things like we often test against illegal argument exceptions. So there's a sugary, nice one right there for you, so you don't even have to write the exception itself. And so that's some nice stuff that's built in. But I have a domain, in this case blackjack, where I wanted to make sure that if you know about blackjack, when you're playing as a player, one of the dealer's cards is face down. It's what's called the hole card. When all the players are done, they flip it over and you see if you beat the dealer. Right? It's one of these games where it's like you're not playing against the other players, you're playing against the dealer. But it turns out like I'd like to test that. And so I could write this. Right? I've got my stub deck builder, which builds a predictable deck, right? Literally stacking the deck so I know what cards I'm going to get when I deal. And I do it from the point of view of what ends up in people's hands, right? Not just here are the cards in this specific order. That's kind of hard to track. You want, like, what do you actually care about? I care that the player will end up with these cards, and I don't care what the dealer gets, just as long as they can't draw any cards. There's some rules about, dealer has to stand on 17 and above. So when the player stands here, I expect that their turn is up, the dealer will not have drawn any cards, and now none of their cards are face down. I don't know about you, but having a little lambda here with a not symbol is easily misread. So we can fix that. Take it and extract out the predicate and give the predicate a name. Much better. Assert that the game dealer hand cards. Okay, that's a little awkward, but okay. They all match the face-up predicate. Great, easy to read. We can go further, extract it out into a named method. Why not? Assert all dealer cards are face-up for this game. And then, like, the details, if they don't matter, hide them away, stuff them into a method. And in tests, I do this much more freely because I don't have to think of like, this is some abstraction. It's like, just put it in a method. And again, at some point, maybe you'll have something more than that because, well, now I've got to assert all dealer cards are face up, assert their whole card is face down. Now you've got a lot of named methods. Well, that might not be so great, right? Same problem as sort of before you went to the test data builder. Well, create a custom assertion that's domain specific. Assert that game, dealer hand, all cards face up. Right, now you've got all the benefits of, so very similar idea, but using the framework, the assertion framework or library, I guess, and you can write this without an assertion library, right? It's another builder-like thing or chain method-like thing, Fluent API, but using domain terms and only the information that I care about is there. Anything else, I don't care about the specific cards. I don't care how you got the dealer's hands and their cards. I care for the dealer hand or all the cards face up. And so meaningful in the domain language of the thing you're dealing with. And that's what's important. So the last thing I'll mention is, at least in Java, we have the challenge of sometimes you want to pull stuff out and hide it away in a method, but you need a couple of pieces from that extracted method. And sometimes you need more than a couple. And so this method was extracted from the top of a test, but we needed to provide, because the rest of the test needed access to a few of these different pieces. And Java has a single return. You can only return one value. If you're doing Java and you're not using IntelliJ, what are you doing? IntelliJ supports when you try to extract a method that is needing some of those values, right? I need the concert store and I need the customer and I need the concert ID for the rest of this test. When you try to extract all that, it doesn't say, oh, I can't do this because you need several of these values that are in the middle here. It says, let me pull it out. I'll give you a record back. And then from that record, you can then access easily that information. And so the last thing I'll end with is something that's a bit controversial, although I don't see why. Well, I do see why, but I don't think it's an issue. And so this idea also came from James Shore, from what he calls nullable infrastructure. But it's sort of the first part of what's really an interesting way to do things, which is if I'm going to create stuff for a test, and it's going to be creating stuff that the object already creates, well, why not just put that creation in the object that you're testing against? And there's this immediate reaction from many people, which is, wait, we don't put test code in our production code. And if you ask them why, most people can't answer that question. And so it's one of those hand-me-down pieces of information where we've lost what was the actual problem we solved with that advice. Why can't we put test-related code in production? Now, if you have in your production code a decision statement that says, if we're in test mode, do this, else if we're in production mode, do that, then yeah, don't do that, please. But if it's creation code, setup code, and the closer you push it to where things might change, especially when refactoring, well, then put your setup code and it returns a fixture. And if I need to change the constructor, well, the code is right there. and it's in one file, and it's easy to change. And again, I've encapsulated it, sort of separated it even further. And this matters a lot more when you have these objects that have other objects that have other objects, where each one you want to configure in a certain way. That's when it really becomes a powerful technique. So I encourage you to read James Shore's Nullable Infrastructure and Testing Without Mocks for more on that. And so, there's the meta question of, like, if you have advice and you're following it, make sure you're following it because you understand what it was protecting you against. Now, it may mean that also, okay, you're shipping some test code inside your production code, but if it's not interacting with it, it's purely for creation to help your setup in your test be easier to use and more resilient to refactoring, that's fine. The minute it starts setting values and changing state and getting involved in decisions, no, then you don't want to do that. In IntelliJ, you can organize your tests in a certain way. I won't go too much into detail about this. There's ways to write your codes that, from an overview, it's very easy to jump to things. So, tests are specific, code is general. That's the idea, right? Lots of examples, because tests are examples, and code is supposed to grow slightly as you generate more examples to handle it. It's not supposed to grow linearly to your examples, otherwise you have no abstractions. And so duplication, literals, a certain amount is fine in tests. You'd like to mostly avoid that in code. Right? Some duplication is good. Make sure you understand why the duplication is there. Right? Don't just remove duplication for no reason. But in general, you want to build abstractions. But that applies to both tests and code, just different kinds of abstractions. And with tests, this is just you can. I feel like I'm a lot more free to do things because there's no dependencies on tests, and that's one of the big differences. And so I think it's actually much easier to refactor your tests because you don't have any code in your production relying on it. So tests are code too. So care about them just as much as your regular code in terms of refactoring, and give them some of the attention they need. And that's all I got for you. So I can take questions now.